Team, last video, this was for kinematics. I wanted to just hit up kinematics because it is one thing that we do talk about a lot in block 1, but we haven't approached it as of late. So I did a writ recently, a writ 6, that kind of encompasses kinematics in itself. So let's read the problem. And a projectile is launched at an angle of 27 degrees and lands 27 seconds later at the same height as it is launched. Okay. Projectile. First hint is kinematics. Second hint, launch at an angle. And lastly, understanding the initial speed of the projectile. All right, this is definitely kinematics. So the first thing is what you have. You have angle and you have time. Okay? And also, one thing. You're given a velocity, or you're not given a velocity, but you're given an angle. If you're given an angle, it means that you have velocity not only in the x direction, but you're also given velocity in the y direction. Okay? Extremely important. Okay, whenever you're given an angle, you have velocity in the x direction, velocity in the y direction. I'm going to put this right here. Bloop. Now, it says a projectile is launched, and we have the time, lands 27 seconds later, at the same height as it was launched. Okay, so basically, it launches at 0. It ends at 0. Height 0. Height 0. And we're given time 2. It says, what is the initial speed of the projectile? Since we're given time, we can definitely, and we know the height, that's the thing. We know the height that it will end up in. Okay? And that height is 0. Because of the way that it was shot, height 0, height 0, it means that we can use one of these equations to actually solve for the initial speed. Actually, there's only one, and it's this one, right here. This one right here is a perfect one. The reason why it's perfect is because it tells you, okay, so if you have the initial height and you have the final height and you have the time and the acceleration, you can definitely solve for the velocity. So we write down in terms of y, not in terms of x, y equals y naught plus v y naught times t minus, because it is negative, it's a negative acceleration, remember that, it is negative acceleration, t squared. Now we replace our values, t0, 0, plus v sine of theta, remember, right here, times t minus g t squared. Now we bring everything to the other side, v naught gt squared over sine of theta t times t. This t cancels out, and we're left with gt over sine of theta. And we have solved for the velocity of the projectile, the initial velocity of the projectile. Okay? If we wanted to find out how much was the distance that it traveled, so this is height, so we identify the height is 0 here and height is 0 here, but if you wanted to solve for the distance traveled, all we had to do was go back to the equation that we use here, and instead of using it in the y direction, we use it in the x direction. X equals x naught plus vx naught t, and then there is no acceleration in the x direction. Remember that. There is no acceleration in the x direction, so we don't have to worry about any acceleration. The only acceleration that we have to worry about is the acceleration due to gravity, and that is used in y. So since we understand that x naught is 0 at a starting point is 0, and vx naught is actually v naught cosine theta times t, now we can solve for the whole distance that it traveled. Then it says calculate the maximum altitude of the projectile. So as the projectile is traveling, it hits its maximum altitude. At the maximum altitude, Vf is equal to 0. Okay? Because once we get to the top, there's no much, and it's not Vf equals 0. It is actually the velocity in the y direction. The velocity in the y direction is equal to 0. So we have this trajectory to study at. Since the velocity in the y direction equals to 0, we can use this equation, because technically we don't have time. We don't really know the time for the middle. Actually, we do, but in case you don't know the time and you're asked to solve for the maximum altitude, then you can use this equation right here to solve for it. So we go velocity y naught, velocity final y naught equals velocity initial y naught squared minus 2g, because it's acceleration under gravity, times the height minus 0, because 0 is where it's starting point. The final velocity goes to 0, and the thing that we have left is v squared, the velocity naught squared, times 2gh. You bring velocity naught over 2g, and you have squared, there we go, squared, and you have your height. Remembering the velocity naught in the y direction is equal to velocity naught sine of theta. And you are done with this problem. Hopefully this was helpful for your kinematics. Just understand that whenever you're given an angle, solve for both the x and the y. You have ability to solve for both the velocity in the x and the y direction. All right? Well, have a good day. This was definitely my last video, and I am very happy about that. I will post, I'm actually going to post it by the time that you hear this, but hopefully these videos were great for you, and I hope that you guys get an A on the T. Bye-bye.